Okay, we're going to move on to problem 2. Select the most stable conformation of this molecule over here, 3-methylpentane. Conformations here are given in this projections here. So in here we're looking at it from this side, meaning when we look at it we have this carbon in the front with a methyl, and this back carbon has a methyl and an ethyl. So we have to worry about the interactions going on between these. And the types of interactions that we've gone over in class are gauche, which is fairly stable but not the most stable. The best being anti, when these bulky methyls are as far away as possible. And our other option is eclipses, which are very bad because they're right on top of each other and bumping into each other. So what we want in this problem is no eclipses, a few amount of gauches, and a high amount of antis to make it very stable. So let's look at them all individually. First we have A, which has, looking at these two that are bumping into each other, one gauche. And it also has that anti over there between the methyl and methyl. But this ethyl and methyl bumping into each other is going to be what we're going to focus on the most, because this ethyl is very bulky, so that's going to be worse than, let's say, a methyl-methyl bumping into each other, because there's more electron clouds bumping into each other, and that costs the molecule. Now we're going to look at B. Here we have another gauche interaction between these two, but in this case it's just a methyl and methyl bumping into each other, and the ethyl over here is far off in the anti position, which is where we want it. So here we only have a gauche, and it's between a methyl and another methyl. Very good. So we'll go on to C, and here we have three things right next to each other bumping into each other, so that's going to put us at two gauches, which is already way worse than the others because it has way more gauches than the rest and no antis. So we'll look at D now. We have a methyl and an ethyl bumping into each other, and an Me at the anti position. Again, we usually want Et to be at the anti position because we want the bulkiest one with more carbons as far away as possible. So here again we have an ethyl and a methyl gauche. Lastly, E and F, we have ethyl and methyl bumping into each other, methyl and ethyl bumping into each other, and this one over here F has two gauche interactions, which again we said was very bad because there's nothing at the anti position. And here we have two ethyls, an ethyl and a methyl bouncing against each other and leaving this at the anti. And again we want Et there, so this is probably not going to be it. And that's going to leave us with A, B, and D. These all have gauche and an anti, but again we want the ethyl to be in that anti position, not only because it's the bulkiest, but because we would be left over with a methyl and a methyl bumping into each other. And a methyl and a methyl bumping into each other is a lot less energy than an ethyl and a methyl. The two things that are the least bulky should be bumping against each other for the best stability.